Hi students, today we'll be seeing about Cohen-Sutherland's line clipping algorithm. Before that, let us see what is generally required for any line clipping algorithm. It needs to test whether the line is within that given clipping window, whether it lies within completely inside or whether it lies completely outside or partial. Partial means that is where our clipping comes into picture. So, result of the testing. So, if the line is completely inside, we need to consider the entire line and say it's visible. If the line is completely outside, then we need to say ignore the line and say it's not visible. When it's partial, then clipping is required. So, these are the clipped images. So, we have the original image and these are the various clipped images that we can see. So, here is where we have the exact line clipping. So, here is our window, clipping window, and these are very many lines. So, this is the image for before clipping and this is the image for after clipping. This, if you can very well see that this line is completely inside the window, so it's visible. This line is completely outside the window, so it's not visible, and the other lines are partially visible. So the visible part alone is highlighted. The rest are just having a shade, just to show that it is not there. Now exactly coming to Cohen-Sutherland line clipping algorithm. So what are the details required? As we saw, we need a clipping window, we need a line, right? So those two are already there. So line will have P and Q as points referred. This is one endpoint, this is the other endpoint. And in Cohen-Sutherland line clipping algorithm, we have this clipping window and the region values. So each region is having a 4-bit binary value with respect to this clipping window. So here if you see, the region value inside the clipping window is all 4 zeros, and the bit positions will be starting from left, right, bottom, top. So this is how the bit positions will be coming. So now this is the clipping window. So here if you see, this is the x minimum, y minimum. So this is the window's x coordinates minimum value and y coordinates minimum value. The same thing applies for all the others. So now what happens, why we need this? Because if any line exceeds anywhere outside, then we need to see whether it is completely outside or partially inside and outside. So now this is the binary code. So here if you see, the bottom of it will have 1, 1, 1, the third bit position, right? So the top of it will have the fourth bit position as 1, 1, 1, and to the left, to the right, this is to the right. If you see, the second bit position is 1, and to the left if you see, the first bit position is 1. So this is our clipping window. We have this window boundary as x minimum and this window boundary as x maximum, this window boundary as y minimum and this window boundary as y maximum. So binary region code representation. So each binary region code indicates the position of the point with respect to the clipping window, and your numbering bit numbers start from bit 1 to 4 from right to left. As we saw, from here right to left. So here bit 1 left position, 2 right, 3 below, 4 above, or you can say bottom or top. Now bit 1 decides the x minimum value, 2 decides the x maximum, 3 decides the y minimum and 4 decides the y maximum value. So how do we set the left, right, bottom and top bits? So we have the boundary values, we have the line endpoints, and then now what we have to do is we have to see what is the binary region code for each endpoint of this line segment, and then check based on that code generated, check the visibility and do clipping if needed. We will see what is that. So if we are given a line, so this is a line segment, we have P and Q as endpoints, P having x, y coordinates, Q having x1, y1 coordinates. So what we have to do is, we have to find the 4-bit binary region code for P, for Q, and then check based on the code, we have to check the visibility test. So this is how these are the rules, that is, x coordinate of that particular point must be compared with x min, y min, y coordinates of that particular point must be compared with y min, y max. So now we have calculated. Suppose both P and Q have this all zeros as their code, binary bit region code, then we can decide the visibility is, the line is fully visible and has to be considered. So now if P and Q have 1 in the same bit position, for example, if P has 1001 and Q has 1000, that is in the 4th bit position, the points P and Q have 1. So it has to be completely ignored. It is completely invisible. So here is where, see, P and Q have all zeros as their 4 bits, so it's completely inside the region. So here if you see, they have a common 1 bit. This 1 bit can be in any bit position. Here I have shown you in the 4th bit position. It can be either in the 3rd, 2nd or 1st. Any bit position, this is the condition. Any bit position, if you see this line segment, the 1 bit position is common, then the line segment lies entirely outside the clipping window and it has to be ignored. Then neither of these cases, that is, you don't have all the zeros or 1 common. So something like this. Suppose if you have 1 000 and Q 010. So here we don't have either 4 zeros for P and Q, or 1 also is not common. So here is where, this is a condition where we need clipping. So sometimes what happens, we may sometimes need to have more number of clippings, and sometimes also what happens is, after clipping the line may disappear. So here if you see, this is the line that we said, P and Q. This needs clipping. So here if you see, P is here, Q is here. So this needs actually clipping. So here if you see, this line is something like this. So this line has been clipped and finally we get the visible part of it. So here this is the given line. We are first clipping at the bottom. So this comes like this. Then clip from the top till this boundary. It has been clipped. Again another clipping has to be done till this boundary, So after finishing all the clippings, finally we have this line as the visible line. So next, what should be done? What is the procedure for clipping? So if the line is completely visible, okay, fine. If the line is completely invisible, then also fine. So now the thing is, we have to see how we should do the clipping part of it. So before going to clipping, we have to find out the slope of the line, which has the given formula y2 minus y1 by x2 minus x1, where we have y2, x1 and y1 are the coordinate values of P, and x2, y2 are the coordinates of Q. P and Q are nothing but the given line segment. So now, we have calculated the slope of the line. So where should we do the clipping part of it? So depending on the code that we have generated, we will be knowing where we have to clip the line. Suppose if it is in the 4th bit position, the line has to be clipped from the given position till the top boundary. So similarly, when it is in the 3rd position, bit position, then the bottom boundary has to be clipped. The line has to be clipped till the bottom boundary, and the 2nd bit position 1, the line has to be clipped till the right. 1st bit position 1, the line has to be clipped till the left boundary. So these are how we have to find out. So these are the new coordinates, that is, we say we have to clip, right? So we have to find out what is the new coordinates for the clipped point. So this is the formula which we have to use for finding out the new coordinates for the clipped point. If the bit position is 1, then this is the formula, 2, this is the formula, 3, this is the formula, 4, this is the formula. So after the new coordinates are calculated, again we have to go for a 4-bit region code. So for that newly calculated line. So here if you see, here we have a line PQ, and then we are clipping the line. We know it is 10000, so this is a 4-bit position. From the top we are clipping to this boundary level. So the point P becomes P dash. Now for this P dash, we need to calculate the region code again. So that is what has been said here. So we need to calculate the binary region code again. Now what we should do, we should compare this P dash with Q again and check for the visibility test. So just seeing the line here itself, we will know we have to clip. Now what happens? So according to this, we have to check the visibility. So when we check the visibility, again we will get a test result that the line has to be clipped. So the entire procedure said above has to be repeated. So now what happens? You are going to clip the point Q to Q dash. So after clipping Q, so now P dash Q dash becomes the new visible line after the clipping is done. So what happens? You have to repeat the clip first. Clipping has to be done. So you have from P to P dash, and again second clipping has to be done. The procedure is the same as mentioned. Q becomes Q dash. Again you have to find out the coordinates for P dash and Q dash and tell the test result as the entire line is visible. So you will have the P dash and Q dash code as 4 zeros. Binary bit position region code is 4 zeros because the line is entirely visible. So now some of the advantages is speeds up the processing of the line segments, reduces the number of intersections calculated. The same thing, if you have so many number of intersecting points, the line intersecting the boundaries, then the calculation becomes tedious because you need to repeat it again and again. Thank you.